Hello there, and welcome to Whispers of Science, where curiosity meets the cosmic and wonder takes the scenic route to understanding. Tonight's gentle journey carries us to the most mysterious place imaginable, the very heart of everything that exists, the center of our universe. It's a place where physics gets strange, reality bends in ways that challenge our deepest assumptions, and scientists are discovering things that sound more like poetry than equations. But before we embark on this voyage to the cosmic core, I'd love to know where in the world you're watching from and what draws you to the mysteries of space. Fitting, isn't it? A video about the center of the universe. And here we are, scattered across the globe, each of us arriving at this moment from our own unique corner of creation. If you find this exploration soothing, intriguing, or simply a peaceful way to drift into wonder, I'd be ever so grateful if you gave the video a like and perhaps subscribed. It helps this quiet corner of cosmic contemplation reach others who might need a moment of celestial calm too. Now, I do hope this journey isn't so captivating that it keeps you from rest, but if it does, well, at least you'll have pondered the deepest mysteries of existence before you close your eyes. So settle in, breathe deeply, and let's begin, because somewhere between the infinitely large and the impossibly distant lies a story that's reshaping everything we thought we knew about where we live. When we speak of the center of the universe, we're not talking about a place you could visit with the most advanced spacecraft humanity might ever build. We're talking about something far more subtle, far more profound than a simple location on some cosmic map. The center of the universe is where the story of everything begins, where the fundamental forces that govern reality itself take their most dramatic bow. It's the stage upon which the greatest cosmic drama ever conceived continues to unfold moment by moment for billions upon billions of years. Imagine, if you will, standing in the middle of a vast ocean, not just any ocean, but one that stretches beyond every horizon. You could ever see an ocean so immense that its edges, if they exist at all, lie beyond the reach of light itself. Now imagine that this ocean isn't made of water, but of space and time, woven together into a fabric so delicate, yet so strong, that it holds galaxies like soap bubbles floating in an endless bath. This is the universe we inhabit, and finding its center, well, that's where things get beautifully complicated. For the longest time, humans believed we were the center of everything. The earth sat motionless, while the sun, moon, and stars danced around us in perfect celestial choreography. It was a comforting thought. Really, we mattered? We were the point around which all creation revolved. Then came Copernicus, with his quiet revolution, suggesting that perhaps we weren't quite so central. After all, the sun he proposed was the true center, and we were merely passengers on a spinning rock that happened to circle it. But even Copernicus couldn't have imagined how much more humble our position would become as telescopes grew more powerful and our understanding deepened. We discovered that our sun was just one star among countless billions in a galaxy we call the Milky Way, and that galaxy itself was just one island universe among countless others scattered throughout an ocean of space so vast that light takes billions of years to cross from one shore to another. The question of where the center might be became not simpler, but infinitely more complex, because as we peered deeper into space, we began to notice something peculiar, something that would revolutionize our understanding of the universe itself. The galaxies weren't just sitting there like stationary islands. They were moving, and not just moving randomly, but moving in a very specific pattern. They were all moving away from us. At first, this observation led to a rather embarrassing conclusion. Were we back to being the center of the universe? After all, had Copernicus been wrong? Were we truly the cosmic navel around which everything else fled in all directions? But as scientists dug deeper into this mystery, they realized something far more profound was happening. The galaxies weren't fleeing from us. Specifically, they were fleeing from each other. The entire universe was expanding, like a balloon being inflated, and from any point within that expanding balloon, every other point would appear to be moving away. This discovery changed everything because in an expanding universe, the question of center takes on an entirely different meaning. Imagine that cosmic ocean again, but now imagine it's not static. Imagine that every drop of water in that ocean is getting farther from every other drop. The ocean itself is growing larger with each passing moment. In such an ocean, where would the center be? The answer is both everywhere and nowhere. Every point in the ocean could claim to be the center, because from any point, every other point appears to be moving away. But here's where the story gets even more intriguing, because scientists have discovered that this expansion isn't happening at a steady, predictable rate. Instead, it's speeding up, accelerating like a car whose driver has decided to floor the gas pedal for reasons we don't entirely understand. Something is pushing space itself apart with ever increasing vigor, and that something has been given the rather ominous name dark energy. Dark energy makes up roughly 68% of everything that exists in our universe, yet we know almost nothing about it. We can't see it, we can't touch it, we can barely detect it except through its effects on the expansion of space itself. It's like trying to understand a ghost by watching the curtains move in a haunted house. You know something is there, something powerful and influential, but the thing itself remains maddeningly elusive. Alongside dark energy, there's another cosmic mystery that scientists are grappling with: dark matter. This invisible substance makes up about 27% of the universe, and while we can't see it directly, we can observe its gravitational effects on the matter. We can see galaxies spin faster than they should based on the visible matter alone. Galaxy clusters bend light in ways that suggest far more mass is present than meets the eye. It's as if the universe is filled with invisible scaffolding holding everything together in ways we're only beginning to comprehend. When we add up everything we can actually see and understand: the stars, galaxies, planets, and all the ordinary matter that makes up you and me and everything we've ever touched, it accounts for less than 5% of the universe. We're like children who have discovered that 95% of their house consists of rooms they've never seen, filled with furniture they can't identify, serving purposes they can't imagine. This realization has profound implications for our understanding of the universe's center, because if most of the universe is invisible to us, how can we possibly map its true structure? How can we identify its center when we can only see a tiny fraction of what's actually there? It's like trying to find the center of a vast city while wearing a blindfold that only allows you to see 5% of the buildings. Yet scientists haven't given up on understanding the cosmic center They've developed ingenious ways to study the invisible universe using gravitational lensing, where the gravity of dark matter bends light from distant galaxies like a cosmic magnifying glass. They've mapped the cosmic microwave background, the faint afterglow of the Big Bang that fills all of space, carrying with it the imprint of the universe's earliest moments. They've used supercomputers to simulate how the universe might have evolved from its earliest moments to the present day. These investigations have revealed something remarkable. The universe appears to have a kind of structure on the largest scales, a cosmic web of filaments and voids that stretches across billions of light years. Galaxies aren't randomly scattered throughout space. Instead, they're organized into vast chains and clusters, connected by bridges of dark matter, while enormous empty regions yawn between them like cosmic caverns. At the intersections of these cosmic filaments, at the nodes where multiple streams of matter converge, scientists have found some of the most massive and ancient structures in the universe, enormous galaxy clusters that serve as cosmic crossroads where the fundamental forces of nature play out their most dramatic performances. These cosmic cities, if you will, contain thousands of galaxies bound together by gravity into structures so massive that they bend space and time around them like cosmic whirlpools. But perhaps the most intriguing discovery of all is that the universe seems to have a kind of memory embedded in its very structure. The patterns we see today, the distribution of galaxies and dark matter, the subtle variations in the cosmic microwave background all carry information about what happened in the universe's earliest moments when it was smaller than an atom and hotter than the core of any star. These cosmic fossils tell us that the universe began in a state of almost perfect uniformity with only the tiniest of fluctuations in density. But those tiny fluctuations were the seeds from which everything we see today would eventually grow over billions of years. Gravity amplified these microscopic variations, turning them into the galaxy's clusters and cosmic web that we observe today. It's as if the entire universe is a vast symphony composed from the faintest of whispers that echoed through space in the moments after creation. The more we learn about these cosmic structures, the more we realize that the center of the universe might not be a place at all, but rather a moment, the moment when everything began, when space and time themselves came into existence. In that blazing instant we call the Big Bang. In this sense, every point in the universe is the center, because every point was there at the beginning when the universe was so small that here and there had no meaning. This perspective transforms our understanding of cosmic center from a question of geography to a question of history. Every atom in your body, every photon of light that reaches your eyes, every breath you take carries within it the memory of that primordial moment when everything that would ever exist was compressed into a space smaller than the period at the end of this sentence. You are not just in the universe, you are the universe experiencing itself from one of its countless perspectives. But scientists have discovered something even more profound lurking at the heart of cosmic structure, something that challenges our most basic assumptions about the nature of reality itself. Deep within the densest regions of the universe, where matter and energy reach their most extreme concentrations, there exist objects so strange, so alien to our everyday experience, that they seem to belong more to the realm of science fiction than scientific fact. These are the places where the fabric of space and time doesn't just bend but breaks, where the laws of physics as we understand them cease to apply, where the very concepts of before and after, up and down, cause and effect lose their meaning. These cosmic anomalies are the subject of intense scientific investigation and heated debate because they may hold the keys to understanding not just the center of the universe, but the fundamental nature of existence itself. They are called black holes, and they represent perhaps the most extreme manifestation of cosmic center that we know of. Imagine a region of space where matter has become so concentrated that it creates a gravitational pull from which nothing, not even light itself, can escape. It's as if the universe has developed a kind of cosmic drain where the normal flow of space and time swirls into an inescapable spiral toward a point of infinite density that physicists call a singularity. But black holes are far more than cosmic vacuum cleaners. They are laboratories where the most fundamental laws of physics are pushed to their absolute limits, where Einstein's equations of general relativity dance with the strange rules of quantum mechanics in ways that still baffle the brightest minds in science at the event horizon, that invisible boundary beyond which nothing can return. The very nature of time begins to behave in ways that seem to mock our everyday experience. From the outside, looking in time appears to slow to a crawl for anything approaching a black hole. A clock falling toward the event horizon would appear to tick slower and slower from our perspective until it seems to freeze entirely at the boundary. Yet from the perspective of the falling clock, nothing unusual happens at all time, flows normally as it crosses the threshold into the unknown. It's as if the universe has two different stories to tell about the same event, and both of them are somehow true. This isn't just theoretical speculation anymore. In recent years, scientists have achieved something that once seemed impossible. They've actually photographed the shadow of a black hole using a network of radio telescopes scattered across the Earth. They've created images of the supermassive black holes that lurk at the centers of galaxies, including our own Milky Way. These cosmic monsters contain millions or even billions of times the mass of our Sun, yet they're concentrated into regions smaller than our solar system. What these observations have revealed is that black holes aren't the simple cosmic drains we once imagined them to be. They're dynamic, complex objects that actively shape the galaxies around them. They feed on surrounding matter, creating brilliant accretion disks that shine brighter than billions of stars. They launch jets of particles at nearly the speed of light that stretch across thousands of light years. They regulate star formation in their host galaxies, like cosmic thermostats, maintaining a delicate balance between creation and destruction. But perhaps most intriguingly, black holes seem to be connected to the fundamental nature of information itself. According to quantum mechanics, information cannot be destroyed. It can be transformed, scrambled, or hidden, but never truly lost. Yet black holes appear to violate this principle by swallowing information along with everything else that crosses their event horizon. This creates what physicists call the information paradox, a puzzle that has consumed some of the greatest minds in science for decades. Stephen Hawking devoted much of his career to understanding this paradox. He discovered that black holes aren't perfectly black after all. They emit a faint radiation, now known as Hawking radiation, caused by quantum fluctuations near the event horizon. This means that black holes slowly evaporate over time, returning their energy to the universe. But the question remains, does this radiation carry information about what fell into the black hole, or is that information lost forever? The answer to this question may determine whether our understanding of physics is fundamentally correct, or whether we need entirely new theories to describe reality. Some scientists propose that information is preserved but in such a scrambled form that it's practically impossible to decode. Others suggest that the inside of a black hole may not exist at all, that the event horizon is like a cosmic hologram that stores information on its surface while appearing three-dimensional from the outside. These ideas lead us to one of the most revolutionary concepts in modern physics, the holographic principle. This suggests that all the information contained in a volume of space can be encoded on its boundary, like a hologram that appears three-dimensional but is actually printed on a flat surface. If this principle is correct, then the entire universe might be a kind of cosmic hologram with all its information stored on a distant boundary that we cannot see or access directly. This brings us back to the question of cosmic center, because if the universe is indeed holographic, then the center might not be where we think it is. The real action, the fundamental processes that determine reality, might be taking place on the boundary, while everything we experience, including ourselves, might be elaborate projections from that distant surface. It's a concept so strange that it challenges our most basic intuitions about the nature of existence. But black holes aren't the only cosmic centers that scientists are studying. There are regions of space where matter and energy concentrate in ways that create their own unique mysteries at the hearts of galaxy clusters. For example, scientists have discovered vast reservoirs of hot gas that outweigh all the visible stars. By factors of 10 or more, these intracluster media, as they're called, reach temperatures of hundreds of millions of degrees and are threaded with magnetic fields that stretch across millions of light years. These cosmic furnaces are laboratories for studying matter under conditions that cannot be replicated anywhere on Earth. The gas is so hot that atoms arrows with X-ray light, thus creating cosmic rays stripped of their electrons, creating a plasma that geomagnetic fields accelerate particles to incredible energy that eventually make their way to Earth and rain down on our atmosphere, providing us with messengers from the most extreme environments in the universe. Within these cluster centers, scientists have also discovered something unexpected: enormous cavities carved out by the jets from central supermassive black holes. These cosmic bubbles can be hundreds of thousands of light years across, larger than our entire galaxy. They represent a kind of cosmic breathing where the central black hole periodically inflates these cavities with its powerful jets, then allows them to collapse before creating new ones in an endless cycle of cosmic respiration. The study of these cluster centers has revealed that the universe operates on cycles and rhythms that dwarf anything we experience in our daily lives. Matter flows in and out of these cosmic hearts over millions of years, creating patterns and structures that persist for billions of years, yet are constantly evolving. It's as if the universe has a kind of metabolism, where energy and matter are digested, processed, and recycled on scales that boggle the human imagination. But perhaps the most profound center of all is the one that started everything, the point, or perhaps the moment, from which our entire universe emerged in the Big Bang. This primordial center isn't a place we can point to in space, because space itself didn't exist before that moment. It's not a time we can locate on a calendar, because time itself began with the expansion. It's something more fundamental than either space or time, yet it gave birth to both. Scientists have pushed their understanding of this cosmic origin story back to within fractions of a second after the Big Bang began. They've traced the evolution of temperature and density through epochs when the universe was a trillion times hotter than the center of the sun, when matter and antimatter annihilated each other in cosmic fireworks, when the first atomic nuclei formed in a process called Big Bang nucleosynthesis that lasted only minutes but determined the composition of matter for all time. Yet the closer they get to the moment of beginning itself, the more mysterious it becomes. The equations of physics break down the concepts of cause and effect, lose their meaning. It's as if there's a veil drawn across the ultimate origin beyond which our current understanding cannot penetrate. Some scientists propose that the Big Bang wasn't really a beginning, but a bounce, that our universe emerged from the collapse of a previous universe in an endless cycle of cosmic death and rebirth. Others suggest that our universe is just one bubble in an infinite foam of universes, each with its own laws of physics, its own dimensions, its own version of reality. In this multiverse scenario, the center of our universe would be just one center among countless others, each equally valid, each containing its own version of the cosmic story. We're trying to understand these ideas, push the boundaries of science into realms that seem almost mystical, yet they emerge from careful mathematical analysis and rigorous scientific reasoning. They remind us that the universe is far stranger and more wonderful than our ancestors ever imagined. That the center we're searching for might not be a place or even a thing, but a principle or a process that underlies all of existence. As we continue our journey toward understanding the cosmic center, we find ourselves confronting questions that seem to blur the line between physics and philosophy, between science and spirituality. What does it mean to be at the center of an infinite universe? How do we comprehend our place in a cosmos where the very concepts of place and position become meaningless at the largest scales? Perhaps the most remarkable discovery in our quest to understand cosmic centers is how they seem to mirror each other across vastly different scales. It's like a cosmic symphony where the same melodies play out whether you're examining the structure of an atom or the architecture of galaxy superclusters. At the heart of every atom lies a nucleus where protons and neutrons huddle together in a space so small that if an atom were the size of a cathedral, its nucleus would be smaller than a marble. Yet this tiny center contains almost all of the atom's mass and determines its entire character. In much the same way, at the heart of every galaxy lies a supermassive black hole that, despite containing only a tiny fraction of the galaxy's total mass, somehow orchestrates the behavior of billions of stars across hundreds of thousands of light years. It's as if the universe has a fondness for creating centers that punch far above their weight in terms of influence, tiny regions that somehow manage to control vast domains around them. This pattern repeats itself at every scale we examine. Solar system orbit around their central stars, star clusters dance around their gravitational centers, even our local group of galaxies slowly orbits around a common center of mass. It's as if the universe has developed a universal organizing principle where matter naturally aggregates into hierarchical structures, each with its own center, each center embedded within larger structures with their own centers, in an endless nested pattern that extends from the quantum realm to the cosmic web itself. But what makes these centers so special? Why does matter seem drawn to organize itself in this way? The answer lies in the fundamental forces that govern reality itself. Gravity, that gentle giant among the forces of nature, has an almost magical property. It's always attractive, never repulsive, and it grows stronger as objects get closer together. This means that any slight concentration of matter will tend to attract more matter, which makes it even more concentrated, which attracts even more matter in a runaway process that scientists call gravitational collapse. Yet gravity alone cannot explain the rich tapestry of cosmic centers we observe, because if gravity were the only force at work, everything in the universe would have collapsed into a single massive black hole eons ago. Instead, we see a delicate balance between forces that create and forces that destroy, between the inward pull of gravity and the outward pressure of heat and motion, between the tendency toward order and the drive toward chaos. This cosmic dance plays out most dramatically in the hearts of stars, where the inward crush of gravity battles against the outward pressure of nuclear fusion. For most of a star's life, these forces exist in perfect equilibrium, creating stable centers where hydrogen atoms fuse into helium, releasing the energy that makes stars shine and ultimately makes life possible. But this balance is temporary, and when it finally breaks, the results can be spectacular. When a massive star exhausts its nuclear fuel, gravity wins the battle. In a dramatic fashion, the star's core collapses in a matter of seconds, creating temperatures and pressures so extreme that they forge the heaviest elements in the universe, then explode outward in a supernova that can briefly outshine an entire galaxy. These stellar death throes scatter the newly formed elements across space seeding future generations of stars and planets with the materials needed for complexity and life. Some stars become so massive that not even a supernova explosion can halt their gravitational collapse. Their cores continue shrinking past the point where atoms can exist, past the point where even neutrons can resist the crush until they become the black holes. We discussed earlier these stellar mass black holes are cosmic lighthouses that reveal themselves through their interactions with surrounding matter, creating some of the most energetic phenomena in the universe. But stellar centers aren't the only places where the forces of creation and destruction wage their eternal battle. In the vast spaces between galaxies, scientists have discovered enormous shock fronts, where galaxy clusters collide at speeds of thousands of kilometers per second. These cosmic train wrecks heat intergalactic gas to temperatures of hundreds of millions of degrees and accelerate particles to energies that dwarf anything we can create in our most powerful particle accelerators. These collision zones represent a different kind of cosmic center, temporary regions where the normal rules of the universe are temporarily suspended, where magnetic fields become tangled into configurations so complex that they defy our ability to model them, where particles surf on shock waves that stretch across millions of light years, gaining energy with each oscillation until they become cosmic rays that eventually find their way to Earth. The study of these extreme environments has revealed something profound about the nature of cosmic centers. They are not static, unchanging things, but dynamic, evolving systems that exist in a constant state of tension between competing forces. They are places where the universe experiments with new possibilities, where the boundaries of what is possible are constantly being tested and redefined. This dynamic nature of cosmic centers has led scientists to a startling realization. The universe may not have one center, but many centers that come and go, appear and disappear as conditions change over cosmic timescales. What we observe today may be just one frame in a cosmic movie that has been playing for nearly 14 billion years and will continue for trillions of years to come. In this view, the search for the universe's center becomes less about finding a specific location and more about understanding the principles that govern how centers form, evolve, and eventually decay. It becomes a study of the fundamental processes that drive cosmic evolution, from the quantum fluctuations in the early universe to the heat death that may await us in the far distant future. Recent observations have revealed that even the cosmic web itself, the largest scale structure we know of, appears to be evolving and changing over time. Computer simulations suggest that the filaments and nodes we see today are temporary features that will eventually merge and separate in a cosmic dance that will reshape the universe over hundreds of billions of years. The centers we identify today may be nothing more than brief eddies in a cosmic river that flows on timescales we can barely comprehend. This perspective forces us to confront the possibility that the very question of where the universe's center is may be fundamentally flawed, not because the question is stupid or meaningless, but because it assumes that the universe is the kind of thing that has a single fixed center, when in reality it may be something far more fluid and dynamic than our everyday experience prepares us to understand. Perhaps the universe is more like a vast ocean where currents and whirlpools form and dissipate in patterns too complex to predict where what appears solid and permanent, from one perspective, reveals itself to be temporary and ephemeral from another, where the very concept of center shifts and changes depending on the scale at which you examine it and the time frame over which you observe it. This brings us to one of the most beautiful and humbling aspects of studying cosmic centers. The more we learn about them, the more we realize how much we don't know. Each new discovery opens up new questions. Each answer reveals new mysteries. Each telescope image shows us structures and phenomena that challenge our existing theories and force us to expand our understanding of what is possible. The James Webb Space Telescope has recently begun to reveal galaxies that existed when the universe was less than 1 billion years old. Galaxies that appear to be more massive and more organized than our theories predicted should be possible. At such early times, these observations suggest that the process of cosmic center formation may have begun earlier and proceeded faster than we thought possible. Meanwhile, gravitational wave detectors have opened up an entirely new window into the universe, allowing us to observe the collisions of black holes and neutron stars events so violent that they create ripples in space-time itself that propagate across billions of light years before finally reaching Earth as whispers of gravitational waves. These observations have revealed that the universe is far more dynamic and violent than we ever imagined, with cosmic centers constantly merging, colliding, and reorganizing themselves in ways we are only beginning to understand. Each of these discoveries reminds us that we are still in the early stages of understanding cosmic centers, that despite all our sophisticated theories and powerful instruments, we are still like children playing on the beach of an infinite ocean, occasionally finding a particularly interesting shell or smooth pebble, while the vast sea of knowledge that stretches out before us largely unexplored. Yet this sense of cosmic humility is also a source of wonder and excitement, because it means that the greatest discoveries may still lie ahead of us, waiting to be found by the next generation of telescopes and detectors, by the next breakthrough in theoretical physics, by the next moment when a scientist looks at familiar data with fresh eyes and suddenly sees a pattern that no one has noticed before. The search for the universe's center is ultimately a search for our own place in the cosmic story, a quest to understand not just where we are, but how we came to be here and what our existence means in the context of the vast and mysterious universe that surrounds us. It is a journey that takes us from the smallest scales of quantum mechanics to the largest scales of cosmic structure, from the earliest moments after the Big Bang to the far future when the last stars will have burned out and the universe will have grown cold and dark. In pursuing this quest, we find ourselves confronting questions that our ancestors could never have imagined, questions about the nature of space and time, about the relationship between matter and energy, about the possibility of multiple universes and the meaning of existence itself. These are not just scientific questions, but profound philosophical and even spiritual inquiries that touch the deepest parts of human curiosity and wonder. As we continue to push the boundaries of our understanding, we may find that the center of the universe is not a place we can visit or even point to, but something far more subtle and profound. Perhaps it exists in the relationships between things rather than in the things themselves. Perhaps it lies in the information that connects distant regions of space, or in the quantum entanglements that link particles across vast cosmic distances. Or perhaps the center of the universe is something even more abstract, a principle or a process that underlies all of physical reality, a kind of cosmic code that determines how matter and energy behave, how space and time are structured, how complexity emerges from simplicity, and how consciousness arises from unconscious matter. These possibilities remind us that the universe may be far stranger and more wonderful than we currently imagine, that our journey us not just to new toward understanding cosmic centers may lead discoveries about the physical world, but to entirely new ways of thinking about reality itself, about what it means to exist in a universe that seems designed to create centers of complexity and beauty and consciousness against all odds. The more we peer into these cosmic centers, the more we discover that they operate according to rhythms and cycles that dwarf anything we experience in our terrestrial lives. Consider the supermassive black hole at the heart of our own Milky Way, a cosmic giant called Sagittarius A star that contains over 4 million times the mass of our Sun, yet remains relatively quiet most of the time, like a sleeping dragon at the center of our galactic home. But occasionally, Perhaps once every few thousand years, it awakens when a star or gas cloud ventures too close, creating a brilliant flare of radiation that illuminates the surrounding space in a spectacular display of cosmic appetite. These feeding events aren't just random occurrences, but part of a larger pattern that scientists are only beginning to understand. Galaxy centers seem to go through phases of activity and quiescence, like cosmic seasons that last millions of years. During active phases, the central black hole feeds voraciously, launching jets of particles that can extend far beyond the galaxy itself. During quiet phases, like the one we're experiencing now, the black hole slumbers, allowing star formation to proceed relatively undisturbed in the galaxy's spiral arms. This cyclical behavior appears to be intimately connected to the evolution of galaxies themselves. The most massive galaxies seem to have gone through multiple cycles of activity, each episode of feeding followed by a period of relative calm. It's as if the universe has developed a kind of cosmic metabolism where energy and matter flow in and out of galactic centers in patterns that regulate the growth and evolution of these vast stellar cities. But the story becomes even more intricate when we consider that galaxies don't exist in isolation. They're embedded in a cosmic web of dark matter, those invisible filaments that stretch across hundreds of millions of light years and serve as highways along which matter flows from one cosmic center to another. Computer simulations reveal that this cosmic web is constantly evolving, with matter streaming along these filaments toward the intersections where galaxy clusters form. At these cosmic crossroads, we find some of the most extreme environments in the universe. Galaxy clusters can contain thousands of individual galaxies, all bound together by gravity into structures so massive that they warp space and time around them like cosmic whirlpools. The space between these galaxies isn't empty, but filled with hot gas that glows with X ray light, creating vast reservoirs of matter that outweigh all the visible stars by enormous factors. Within these cluster centers, scientists have discovered phenomena that challenge our understanding of physics itself. Magnetic fields thread through the hot gas, creating structures that can span millions of light years, yet maintain their coherence for hundreds of millions of years. These magnetic highways accelerate particles to incredible energies, creating cosmic rays that eventually make their way across the universe to rain down on planets like Earth, carrying with them information about the most extreme processes in nature. The central galaxies in these clusters often show signs of having consumed their smaller neighbors over cosmic time, growing fat on a diet of galactic cannibalism. Their central black holes have grown correspondingly massive, some containing billions of times the mass of our Sun. These cosmic giants create feedback loops that regulate star formation, not just in their own galaxy, but throughout the entire cluster, like cosmic thermostats that maintain a delicate balance between creation and destruction. Recent observations have revealed that these cluster centers are connected across vast distances by invisible threads of dark matter and energy. Galaxy clusters don't evolve in isolation, but are part of an even larger structure that scientists call the cosmic web. This web appears to have nodes and connections that span significant fractions of the observable universe, suggesting that the entire cosmos might be organized like a vast neural network with information and energy flowing along pathways we're only beginning to map. This network like structure raises profound questions about the nature of cosmic centers. If the universe resembles a vast brain with galaxy clusters, as neurons connected by filaments of dark matter, then perhaps the center we're looking for isn't a single location, but a distributed system where consciousness or information processing occurs on scales we can barely imagine. Some scientists have even speculated that the universe might be capable of a kind of cosmic cognition, with thoughts occurring over timescales of billions of years. These ideas push us into realms where science begins to merge with philosophy and even theology. If the universe is indeed capable of some form of awareness or information processing, then our own consciousness might be just one manifestation of a much larger cosmic mind. We might be thoughts in the universe's contemplation of itself, brief flickers of awareness in a vast cosmic neural network that spans space and time in ways that dwarf our ordinary understanding. The search for cosmic centers has also led scientists to examine the very early universe, when it was so young and small that quantum effects dominated its behavior. During this epoch called inflation, the universe underwent a period of exponential expansion that stretched tiny quantum fluctuations to cosmic scales. These primordial ripples in spacetime eventually became the seeds from which all cosmic structure would grow, including the centers we observe today. The cosmic microwave background radiation carries the imprint of these quantum fluctuations, frozen into the sky like a baby picture of the universe taken when it was only 380,000 years old. By studying this ancient light in exquisite detail, scientists have been able to map the distribution of matter and energy in the early universe with remarkable precision. These maps reveal that even in its infancy, the cosmos showed signs of the hierarchical structure we see today, with regions of slightly higher density that would eventually become galaxy clusters and cosmic centers. But the cosmic microwave background also contains puzzles that challenge our understanding. There appear to be patterns in this ancient radiation that are difficult to explain using our current theories of cosmic evolution. Some scientists have suggested that these anomalies might be evidence of processes that occurred before inflation, during an even earlier epoch when the universe was governed by physics we don't yet understand. These pre-inflationary processes might have left their signature not just in the cosmic microwave background, but in the very structure of space-time itself. If this is true, then the centers we observe today might carry within their structure information about the ultimate origin of the universe, encoded in ways we're only beginning to decipher. Every galaxy cluster, every black hole, every filament of the cosmic web might be a kind of cosmic fossil that preserves evidence of the most fundamental processes that brought our universe into existence. This perspective transforms our understanding of cosmic centers from mere collections of matter and energy into repositories of cosmic memory. Each center becomes a library where the history of the universe is written in the language of gravity and electromagnetism, in the dance of particles and the flow of space-time itself. Reading this cosmic library requires new tools and new ways of thinking, but the rewards might include answers to the deepest questions about existence itself. The development of gravitational wave astronomy has opened up entirely new chapters in this cosmic library. When black holes merge, they create ripples in spacetime that carry information about the most extreme gravitational environments in the universe. These waves propagate across billions of light years, carrying with them the signatures of cosmic centers in their most violent and dynamic states. Each gravitational wave detection is like receiving a message from the universe's most extreme regions, places where the fabric of space-time itself is stretched and compressed in ways that test the limits of Einstein's equations. These signals have revealed that black hole mergers are far more common than scientists expected, suggesting that the universe is filled with cosmic centers that are constantly interacting, merging, and evolving in a vast choreography of spacetime. The information carried by gravitational waves has also revealed that the universe's centers come in varieties we never suspected. Some black holes appear to be spinning at nearly the maximum rate allowed by physics, their rotation dragging spacetime around them like thick honey. Others seem to have formed through processes we don't fully understand, with masses and properties that challenge our theories of stellar evolution and cosmic structure formation. As detectors become more sensitive, we're beginning to hear the gravitational wave equivalent of cosmic background noise, a constant susurrus of ripples created by countless mergers and interactions throughout the universe. This gravitational wave background might eventually allow us to map the distribution of cosmic centers throughout space and time, creating a kind of cosmic seismology that reveals the hidden architecture of the universe. But perhaps the most profound implication of gravitational wave astronomy is what it tells us about the nature of spacetime itself. These waves demonstrate that space and time aren't fixed stages upon which cosmic drama unfolds, but active participants in the story. They can be stretched and compressed, twisted so and curved, made to ring like cosmic bells when disturbed by the most extreme events in nature. This dynamic view of spacetime has led some scientists to propose that the universe might be far more flexible and malleable than we previously imagined. If spacetime can be manipulated by sufficiently extreme conditions, then perhaps the centers we observe today are just one configuration among many possible arrangements. The universe might be capable of reorganizing itself in ways that could create entirely new types of centers, new forms of cosmic organization that we haven't yet imagined. These possibilities remind us that our journey toward understanding cosmic centers is far from over. Each new discovery opens up new questions. Each answer reveals new mysteries. We're still in the early stages of mapping the universe's hidden architecture, still learning the cosmic language in which the deepest truths about existence are written. The centers we've discovered so far might be just the beginning, the first glimpses of a cosmic symphony whose full scope and beauty we're only starting to appreciate. As we venture deeper into this cosmic mystery, we encounter something that challenges our very perception of what centers mean in the vast expanse of existence. Scientists have recently discovered that the universe contains structures so immense that they dwarf even galaxy clusters, formations that stretch across billions of light years and appear to pulse with a kind of cosmic heartbeat that resonates through the fabric of space itself. These are the cosmic walls and supervoids, regions where matter has organized itself into patterns so grand that light takes hundreds of millions of years to cross from one edge to another. Imagine sheets of galaxies arranged like soap bubbles in a cosmic foam with enormous empty regions between them that contain almost nothing at all. These structures suggest that the universe has a kind of architecture on the largest scales, a blueprint that governs how matter arranges itself across distances that boggle the human mind. Within these vast walls, scientists have identified what they call attractors, regions where the gravitational pull is so strong that it influences the motion of galaxies across hundreds of millions of light years. The Great Attractor, hidden behind the dust and stars of our own Milky Way, tugs on our galaxy and thousands of others with an invisible hand that speaks of mass concentrations beyond our current ability to fully map or understand. But here's where the story takes an even more intriguing turn, because these cosmic attractors aren't stationary features, but appear to be moving themselves, flowing along currents in the cosmic web like massive ships riding invisible rivers of dark matter. The universe, it seems, has a kind of circulation system where matter and energy flow in patterns that connect the most distant regions of space in ways we're only beginning to comprehend. This cosmic circulation has led some researchers to propose that the universe might have a kind of metabolism, with cycles of expansion and contraction that play out over timescales that dwarf the age of stars and galaxies. During certain phases, matter might flow toward cosmic centers with unusual intensity, creating periods of enhanced star formation and black hole growth. During other phases, the flow might reverse or stagnate, leading to cosmic quiet periods when the universe enters a kind of dormant state. These metabolic cycles might explain some of the puzzling observations that have emerged from deep space surveys. Astronomers have found galaxies that appear to be more mature and organized than they should be given the age of the universe, as if cosmic evolution proceeded faster in the early universe than our current theories predict. Perhaps these galaxies formed during periods of enhanced cosmic circulation, when the flow of matter toward centers was particularly vigorous. The study of these cosmic flows has also revealed something unexpected about the nature of empty space itself. The regions between galaxy clusters, once thought to be nearly empty, appear to contain vast networks of gas filaments that glow faintly with the light of hydrogen atoms excited by cosmic radiation. These cosmic spider webs connect distant galaxy clusters and serve as conduits along which matter and energy can flow across the universe. But perhaps most remarkably, scientists have discovered that these cosmic filaments appear to be rotating, spinning slowly, like cosmic cables twisted by some unimaginable force. The rotation is so gradual that it takes hundreds of millions of years to complete a single turn, yet it's measurable using the most sensitive astronomical instruments. This cosmic spin suggests that the universe has a kind of angular momentum on the largest scales, as if the entire cosmos is slowly rotating around some axis we haven't yet identified. The implications of cosmic rotation are profound because they suggest that the universe might have a preferred direction, a cosmic axis that breaks the assumed symmetry of space. If this is true, then the center of the universe might not be a point, but a line, an axis around which everything else revolves in a stately cosmic dance that plays out over billions of years. Recent observations from space based telescopes have begun to map this potential cosmic rotation in unprecedented detail. By studying the polarization of light from distant galaxies, scientists can detect subtle signs of cosmic scale magnetic fields that might be aligned with this hypothetical rotation axis. These observations are still preliminary and hotly debated, but they hint at the possibility that the universe has a kind of cosmic grain, a fundamental asymmetry that influences how matter and energy behave on the largest scales. Whoop. The search for this cosmic axis has led researchers to examine the cosmic microwave background radiation with new eyes, looking for subtle patterns that might reveal the universe's preferred direction. Some studies have claimed to find evidence of such patterns, while others have failed to confirm these results. The debate continues, but it represents a fundamental shift in how we think about cosmic structure and the nature of space itself. If the universe does indeed have a preferred axis, then every cosmic center we observe might be influenced by this grand rotation, like eddies in a vast cosmic river that flows in ways we're only beginning to understand. The black holes at galactic centers, the hot gas in galaxy clusters, even the formation of stars and planets might all be subtly influenced by this cosmic spin. This brings us to one of the most beautiful aspects of studying cosmic centers, the way they seem to mirror patterns found in nature at every scale. Just as water swirling down a drain creates a vortex with a well defined center, matter falling into black holes creates accretion disks with their own spiral structure. Just as hurricanes on Earth organize themselves around calm eyes, galaxy clusters appear to have quiet central regions surrounded by turbulent outer zones. These parallels suggest that the universe operates according to principles that transcend scale, fundamental laws that govern how matter and energy organize themselves, whether we're looking at a whirlpool in a bathtub or a galaxy cluster millions of light years across. The mathematics that describe fluid flow on Earth turn out to be surprisingly similar to the equations that govern the behavior of cosmic plasma in the most extreme environments of space. This universality of pattern has led some scientists to propose that the study of cosmic centers might reveal fundamental principles of organization that apply far beyond astronomy. The way matter flows toward cosmic centers, the way energy is dissipated and redistributed, the way information is processed and stored in these extreme environments, all might provide insights into the basic rules that govern complex systems throughout nature. Consider how a galaxy forms around its central black hole, with gas and dust spiraling inward while stars form in the surrounding disk. The black hole regulates this process through feedback mechanisms that prevent too much matter from accumulating too quickly, maintaining a delicate balance that allows the galaxy to grow steadily over billions of years. This is remarkably similar to how ecosystems on Earth regulate themselves, with feedback loops that maintain stability while allowing for growth and change. The study of cosmic centers has also revealed the importance of boundaries, the interfaces between different regions where the most interesting physics often occurs. At the event horizon of a black hole, space and time behave in ways that challenge our understanding of causality and information. At the edges of galaxy clusters, cosmic shocks accelerate particles to incredible energies, while magnetic fields become tangled into complex configurations that generate radio waves detectable across the universe. These boundary regions, are where the universe experiments with new possibilities, where the normal rules are stretched and sometimes broken in ways that reveal deeper truths about the nature of reality. They're cosmic laboratories where conditions exist that cannot be replicated anywhere on Earth, providing unique opportunities to test our theories of physics under the most extreme circumstances imaginable. The James Webb Space Telescope has begun to reveal these boundary regions in unprecedented detail, showing us how matter behaves at the edges of black hole accretion disks, how stars form in the turbulent environments around galactic centers, how cosmic rays are accelerated in the shock fronts where galaxy clusters collide. Each image brings new surprises and new questions about the fundamental processes that shape cosmic evolution. But perhaps the most profound boundary of all is the one that separates the observable universe from whatever lies beyond. The cosmic horizon, the distance beyond which light hasn't had time to reach us since the beginning of time, represents the ultimate limit of our current knowledge. Beyond this boundary lie regions of the universe that remain forever hidden from our direct observation, cosmic centers that we can never see or study directly. Yet even this ultimate boundary is not fixed, but constantly expanding as the universe ages and light from more distant regions finally reaches us. Every day, we can see a little farther into space and further back in time, gradually expanding our cosmic horizon and revealing new chapters in the story of cosmic evolution. In a very real sense, the observable universe is growing, and with it, our understanding of the cosmic centers that lie within it. This expanding horizon reminds us that our knowledge of cosmic centers is necessarily incomplete, that we're always working with a partial picture of a much grander cosmic architecture. The centers we can observe might represent only a tiny fraction of what actually exists, like trying to understand a vast city by peering through a keyhole. Yet even this limited view has revealed wonders beyond imagination and continues to surprise us with new discoveries that challenge our preconceptions about the nature of existence. The quest to understand cosmic centers has also led scientists to develop new technologies and techniques that push the boundaries of human engineering. Gravitational wave detectors that can measure distortions in space-time smaller than 1,000th the width of a proton. Radio telescope arrays that span continents to create images of black hole event horizons. Space-based observatories that can detect the faintest whispers of X-ray emission from the hottest gas in the universe. Each of these technological marvels represents humanity's determination to understand our place in the cosmic story, to push beyond the limitations of our earthbound perspective and glimpse the vast machinery that governs the universe on its largest scales. They're testament to our species' unique ability to imagine worlds beyond our direct experience and then build tools sophisticated enough to make those worlds visible. As we continue to develop these tools and refine our techniques, we can expect even more surprising discoveries about the nature of cosmic centers. Future detectors might reveal gravitational waves from the collision of primordial black holes formed in the earliest moments after the Big Bang. Next generation telescopes might image the shadows of black holes in distant galaxies, allowing us to study how these cosmic engines evolved over billions of years. The coming decades promise to be a golden age for the study of cosmic centers, as multiple new technologies come online simultaneously and begin to work together in ways that amplify their individual capabilities. The combination of gravitational wave astronomy, high resolution imaging of black holes, precision measurements of cosmic expansion, and detailed mapping of the cosmic web will create a multidimensional view of cosmic structure that our predecessors could never have imagined. Yet, for all these technological advances, the fundamental questions about cosmic centers remain as mysterious as ever. We still don't know why the universe chose to organize itself in hierarchical structures with centers at every scale. We don't understand why some regions of space become cosmic crossroads while others remain forever empty. We can't predict where the next generation of cosmic centers will form or how the current ones will evolve over cosmic time. These enduring mysteries remind us that the universe still holds secrets that may require entirely new ways of thinking to unlock. Perhaps our current concepts of space and time are too limited to fully capture the nature of cosmic centers. Perhaps we need new mathematics, new physics, even new forms of consciousness to truly understand our place in the cosmic story. But that uncertainty is also what makes the quest so compelling, because it means that the greatest discoveries might still lie ahead of us, waiting to be found by the next generation of cosmic explorers. Every time we think we understand the universe's centers, they surprise us with new behaviors, new connections, new depths of complexity that humble our pretensions to knowledge and fill us with renewed wonder at the magnificent cosmos we inhabit. And perhaps this is where our journey through cosmic centers brings us to the most profound realization of all, that we ourselves might be among the universe's most remarkable centers, not in the old geocentric sense, where Earth sat at the physical heart of creation, but in a far more subtle and beautiful way. Each conscious being represents a point where the universe has organized matter and energy into configurations complex enough to contemplate their own existence, to wonder about their place in the cosmic story, to reach out across vast distances and times in search of understanding. Consider the extraordinary sequence of events that had to unfold for you to be here, listening to these words, pondering these cosmic mysteries. Stars had to live and die to forge the heavy elements in your body. Galaxies had to form and evolve to create the stable environments where planets could develop. Both. The cosmic web had to arrange itself just so, creating the density fluctuations that would eventually become the stellar nurseries where our sun was born. Countless cosmic centers had to function perfectly over billions of years to create the conditions necessary for complexity, for life, for consciousness. In this sense, every thinking being is the product of cosmic centers working in harmony across space and time. The calcium in your bones was forged in the hearts of massive stars. The iron in your blood was created in supernova explosions that briefly outshone entire galaxies. The oxygen you breathe was synthesized in stellar furnaces and scattered across space by stellar winds. You are, quite literally, made of star stuff, assembled by cosmic processes into a configuration capable of understanding its own cosmic heritage. But consciousness represents something even more remarkable than the mere assembly of cosmic materials. It creates what we might call experiential centers, points where the universe becomes aware of itself, where cosmic evolution gives rise to reflection, wonder, and the capacity for meaning making. When you gaze up at the night sky and feel that sense of cosmic vertigo, that awareness of your smallness in the face of such vastness, you're participating in one of the universe's most extraordinary achievements, the emergence of beings capable of cosmic consciousness. This perspective transforms the question of cosmic centers from a purely physical inquiry into something that touches the deepest aspects of what it means to exist. Perhaps the most important centers in the universe aren't the black holes or galaxy clusters we've been discussing, but the countless points where matter has organized itself into forms capable of love, creativity, compassion, and understanding. Perhaps consciousness itself represents a new kind of cosmic center, one that operates according to principles we're only beginning to explore. Recent discoveries in neuroscience and psychology have revealed that our brains operate with remarkable similarities to cosmic structures. Neural networks process information through patterns of connection and communication that mirror the cosmic web on much smaller scales. The way memories form and fade, the way consciousness emerges from unconscious processes, the way individual neurons coordinate to create coherent thoughts and experiences, all suggest that the organizational principles we see in cosmic centers might extend into the realm of mind and consciousness. Some researchers have even proposed that consciousness itself might be a fundamental feature of the universe, not something that emerges only in complex biological systems, but a basic property that exists wherever information is processed and integrated. If this is true, then the cosmic centers we've been exploring might possess their own forms of awareness, vast, slow thoughts that unfold over millions of years as matter flows through their gravitational embrace. This idea pushes us into realms where science meets philosophy and even spirituality. Could the supermassive black hole at our galaxy's center be aware of the billions of stars that orbit around it? Might galaxy clusters process information about their cosmic environment in ways that constitute a form of thinking? Could the cosmic web itself be a kind of universal nervous system, with thoughts propagating along dark matter filaments at the speed of gravitational waves? These questions may sound fantastical, but they emerge naturally from our growing understanding of how information and consciousness work. We now know that complex systems can exhibit emergent properties that are more than the sum of their parts. A flock of birds can navigate with a collective intelligence that exceeds what any individual bird possesses. Ant colonies can solve problems that would baffle individual ants. Perhaps cosmic structures exhibit similar forms of collective intelligence on scales we're only beginning to imagine. The search for cosmic centers has also led us to contemplate the nature of time itself in new ways. We've discovered that different regions of the universe experience time differently, that the flow of temporal experience depends on gravity, velocity, and the local curvature of spacetime. Near black holes, time slows to a crawl. In the vast empty spaces between galaxy clusters, time flows at its most rapid pace. This means that the universe doesn't have a single universal now, but countless different temporal flows that create a rich tapestry of temporal experience. If consciousness does exist in cosmic centers, it might experience time in ways that are utterly alien to our biological perspective. A thought in a galactic center might unfold over millions of years, processing information about stellar births and deaths, about the slow dance of spiral arms, about the gradual accumulation of matter in the central black hole. From such a perspective, the rise and fall of entire civilizations might appear as brief flickers, while the evolution of the galaxy itself would be the primary focus of attention. This temporal perspective challenges our assumptions about what kinds of processes can constitute mind or consciousness. We tend to think of consciousness as something that operates on timescales similar to our own, with thoughts forming and dissolving over seconds or minutes. But there's no fundamental reason why consciousness couldn't operate on much longer or shorter timescales, experiencing reality at temporal rhythms that are completely foreign to biological experience. The quantum world already provides examples of information processing that occurs on timescales far shorter than anything in our everyday experience. Still, quantum computers can perform certain calculations by exploring multiple possible solutions simultaneously, using the strange properties of quantum superposition to achieve computational speeds that classical computers cannot match. Perhaps cosmic centers utilize similar quantum processes, but stretched across vast scales of space and time to process information about the universe's evolution in ways we're only beginning to understand. These possibilities remind us that our journey toward understanding cosmic centers is also a journey toward understanding ourselves and our place in the grand cosmic story. Every discovery about how the universe organizes itself on the largest scales tells us something about the processes that created us, the environments that nurtured the development of complexity and consciousness, the cosmic inheritance that shapes our deepest nature. The elements in our bodies carry the signatures of the cosmic centers where they were forged. The patterns of activity in our brains echo the organizational principles that govern galaxy formation. The rhythms of our biological processes reflect the cycles of stellar birth and death that have played out over billions of years. We are not separate from the cosmic centers we study, but intimately connected to them through bonds forged in the hearts of stars and shaped by the evolution of the universe itself. This connection extends beyond the merely physical to encompass the realm of meaning and purpose, the capacity for wonder that drives our exploration of cosmic centers, the sense of beauty we experience when contemplating the universe's vast architecture, the deep satisfaction that comes from understanding our place in the cosmic story. All of these represent ways that consciousness transforms mere physical processes into something richer and more meaningful. Perhaps this is the ultimate center we've been searching for all along. Not a location in space or a moment in time, but the capacity for meaning making itself, the ability to transform raw physical processes into stories, purposes, and values that give significance to existence. In this view, every conscious being represents a cosmic center of meaning, a point where the universe's evolution has created the capacity for significance, beauty, and purpose. The implications of this perspective are profound because they suggest that consciousness and meaning are not accidental byproducts of cosmic evolution, but fundamental features of how the universe organizes itself. The same principles that create cosmic centers on the largest scales also create centers of experience and meaning wherever matter achieves sufficient complexity and integration. The universe, in this view, is not merely a collection of particles moving through space according to mathematical laws, but a vast system for generating and exploring possibilities, for creating new forms of order and complexity, for bringing meaning and consciousness into existence. This understanding transforms our relationship with the cosmos from one of separation and alienation to one of intimate participation. We are not strangers in a foreign universe, but expressions of the universe's deepest nature, manifestations of its capacity for self awareness and self understanding. When we study cosmic centers, we are the universe studying itself, using the tools of consciousness to explore the very processes that gave consciousness birth. The story of cosmic centers thus becomes a story about the universe's journey towards self understanding, a epic tale of matter and energy organizing themselves into ever more complex and beautiful forms, eventually giving rise to beings capable of contemplating the whole magnificent process. From the first quantum fluctuations in the primordial universe to the emergence of conscious minds capable of cosmic wonder, the entire sequence represents a single, unfolding story of cosmic creativity and self discovery. As we continue to explore these mysteries, as our instruments become more sensitive and our theories more sophisticated, we participate in this cosmic journey of self understanding. Each new discovery about black holes and galaxy clusters, about dark matter and cosmic expansion, about the formation and evolution of cosmic structure, adds another chapter to the universe's autobiography, written in the language of mathematics and expressed through the poetry of scientific discovery. The centers we seek may ultimately be found not in the distant reaches of space, but in the depths of our own capacity for wonder and understanding. Every moment of cosmic contemplation, every flash of scientific insight, every experience of beauty in the face of cosmic vastness represents a center where the universe achieves a new level of self awareness, where the long journey from quantum foam to conscious mind reaches a moment of fulfillment. And perhaps that is the most beautiful discovery of all, that in seeking the center of the universe, we have found that we ourselves, along with all conscious beings throughout the cosmos, are among the universe's most precious and remarkable centers. We are the points where 14 billion years of cosmic evolution have culminated in the capacity for wonder, understanding, and love. We are the universe becoming aware of itself, celebrating its own magnificent complexity through the eyes of consciousness. In this quiet moment, as you contemplate these vast mysteries, you participate in one of the cosmos's most extraordinary achievements. Your capacity for wonder, your ability to imagine distant galaxies and contemplate the nature of existence itself, represents the universe's ongoing project of self discovery. You are both observer and participant, questioner and answer, a cosmic center of consciousness embedded within the vast network of centers that stretches across all of space and time. The journey continues, the questions multiply, and the wonder deepens with each new discovery. Somewhere in the darkness between galaxies, cosmic filaments pulse with the slow heartbeat of universal evolution. Somewhere in the depths of space, black holes dance their gravitational ballet, creating ripples that carry information across billions of years. Somewhere in the quantum foam of the vacuum, new possibilities flicker into existence and fade away in patterns too subtle for our current understanding. And here, in this moment, in the quiet space between heartbeats, between thoughts, between the familiar and the infinite, consciousness touches the edge of cosmic mystery and finds itself reflected in the very structures it seeks to understand. The center of the universe, it turns out, is not a place, but a process, not a location, but a relationship, not a destination, but a journey that includes every conscious moment, every flash of understanding, every instant of wonder at the magnificent cosmos we call home. The search for cosmic centers has revealed something even more profound about the nature of reality itself, that the universe appears to possess what scientists are calling memory. Not the kind of memory you or I might have, filled with personal experiences and learned associations, but something far more fundamental: the capacity to encode information about its own past in the very structure of space and time. Consider how a galaxy preserves the story of its formation in the orbital patterns of its stars. The oldest stars, formed when the galaxy was young and chaotic, follow elongated orbits that carry them far from the galactic center and back again in great sweeping arcs. Meanwhile, younger stars born in the settled disk follow neat circular paths, like children who've learned to walk in orderly lines. Each stellar orbit is a kind of cosmic handwriting, recording the gravitational conditions that existed when that star first condensed from interstellar gas. But this cosmic memory extends far beyond individual galaxies. The cosmic web itself, that vast scaffolding of dark matter filaments connecting galaxy clusters across billions of light years, preserves information about the universe's earliest moments. The pattern of density fluctuations that existed when the cosmos was barely 380,000 years old has been amplified by billions of years of gravitational evolution, but the original blueprint remains visible to those who know how to read it. It's rather like examining tree rings to understand ancient climate patterns, except the rings we're reading stretch across intergalactic space and record not seasonal variations, but the fundamental processes that shaped reality itself. Scientists can look at the distribution of galaxies today and work backward, like cosmic archaeologists, to reconstruct what the universe looked like when it was a fraction of its current age. This cosmic memory has led researchers to a startling realization. Information itself might be one of the fundamental organizing principles of the universe. Just as matter and energy flow toward cosmic centers under the influence of gravity, information appears to accumulate and concentrate in ways that create increasingly complex structures. Stars are information processing systems that convert hydrogen into heavier elements according to the precise rules of nuclear physics. Galaxies are vast databases that store the history of stellar formation and destruction across billions of years. Black holes represent the ultimate information repositories, regions where the normal rules of spacetime break down, but where information might be preserved in forms we're only beginning to understand. Stephen Hawking's famous paradox about information falling into black holes has sparked decades of theoretical work exploring how the universe prevents information from being truly lost. The leading solutions all point toward the same conclusion. Reality itself appears to have an intrinsic bias toward preserving and organizing information, even under the most extreme conditions imaginable. This information centric view of cosmic centers has profound implications for our understanding of consciousness and intelligence. If the universe naturally tends to create structures that process and store information, then the emergence of conscious minds might not be an unlikely accident, but an inevitable consequence of cosmic evolution. We might be living in a universe that is fundamentally oriented toward creating ever more sophisticated forms of information processing and storage. Recent discoveries in astrobiology have begun to explore how this cosmic information flow might relate to the emergence of life itself. The chemistry that drives biological processes appears to be remarkably similar to the chemistry that occurs in interstellar space, where complex organic molecules form spontaneously in the cold vacuum between stars. The amino acids that form proteins, the nucleotides that make up DNA, even the lipids that create cell membranes, all of these fundamental building blocks of life have been detected in cosmic dust clouds and meteorites. This suggests that life might not be a rare deviation from cosmic norms, but a natural expression of the universe's tendency to create increasingly complex information processing systems. The same forces that drive the formation of galaxy clusters and cosmic webs might also drive the emergence of metabolism, reproduction, and eventually consciousness. We might be living in what some researchers call a biophilic universe, a cosmos inherently friendly to the development of life and mind. The implications become even more intriguing when we consider that conscious minds are perhaps the most sophisticated information processing systems we know of. A human brain contains roughly as many neurons as there are stars in the Milky Way galaxy, all interconnected in patterns of staggering complexity. The information processing that occurs during a single moment of conscious experience involves computational processes that dwarf anything we've achieved with artificial intelligence. If consciousness represents the universe's most advanced information processing technology, then conscious beings might play a crucial role in cosmic evolution itself. We might be the universe's way of understanding itself, of processing and integrating information about cosmic structure and evolution in ways that pure physical processes cannot achieve. Every scientific discovery, every moment of cosmic wonder, every flash of understanding about the nature of reality might represent the universe achieving new levels of self awareness. This perspective suggests that the search for cosmic centers might ultimately lead us to recognize that consciousness itself represents a new kind of cosmic center, not a physical location, but a process, a way that matter and energy can organize themselves to create awareness, understanding, and meaning. The centers we observe in space, black holes, galaxy clusters, cosmic web nodes, might be the universe's way of creating the conditions necessary for consciousness to emerge and flourish. The cosmic microwave background radiation provides another layer to the story of cosmic memory and information. This faint afterglow of the Big Bang carries encoded within its subtle temperature variations a complete record of the universe's state when it was only a few 100,000 years old. By studying this ancient light with increasingly sensitive instruments, scientists have been able to read the universe's baby pictures with extraordinary precision. But the cosmic microwave background contains more than just historical information. It also appears to contain hints about the universe's future evolution. The patterns of temperature variation encode information about the density of matter and dark energy throughout space, which determines how the cosmic web will continue to evolve over billions of years to come. In a very real sense, the universe's past contains a blueprint for its future, written in the language of quantum fluctuations and gravitational waves. This temporal interconnectedness, where past, present, and future are woven together in the fabric of space time itself, not just in space, but in time, suggests that cosmic centers might exist. The Big Bang itself represents a kind of temporal center from which all of cosmic history unfolds. Every moment since then carries information about that primordial instant while also contributing to the information that will shape future cosmic evolution. Recent theoretical work in cosmology has begun to explore whether time itself might have a kind of directionality that extends beyond the familiar arrow of thermodynamic time. Some models suggest that the universe might be evolving towards states of ever greater complexity and information content, driven by the same forces that create cosmic centers in space. If this is true, then consciousness and intelligence might represent the leading edge of cosmic evolution, the universe's exploration of entirely new possibilities for organizing matter, energy, and information. The study of cosmic inflation, that brief period of exponential expansion in the universe's earliest moments, has revealed that even the most fundamental features of spacetime might carry information about cosmic centers. The quantum fluctuations that occurred during inflation were stretched to cosmic scales, creating the density variations that would eventually become galaxies and galaxy clusters. But these fluctuations also appear to have imprinted information about the inflation process itself into the structure of spacetime. Some theories suggest that the patterns of cosmic microwave background radiation might contain signatures of the specific physics that drove inflation, potentially revealing information about energy scales and particle interactions that occurred when the universe was far smaller than an atomic nucleus. If we can learn to read these cosmic signatures correctly, we might gain access to information about the universe's birth that is preserved nowhere else in nature. This brings us to one of the most remarkable aspects of studying cosmic centers: the way they connect us to the deepest mysteries of existence while remaining grounded in observable phenomena. Every telescope image of a galaxy cluster, every detection of gravitational waves from merging black holes, every measurement of cosmic expansion represents both a scientific achievement and a moment of cosmic communion. We're not just studying distant objects, but participating in the universe's ongoing project of self discovery. The technological achievements required to detect and study cosmic centers represent some of humanity's greatest intellectual accomplishments. The Laser Interferometer Gravitational Wave Observatory can detect distortions in space-time that are smaller than 1/10,000th the width of a proton. The Event Horizon Telescope creates images of black hole shadows by coordinating radio telescopes scattered across the entire Earth. The James Webb Space Telescope can observe galaxies that formed when the universe was less of its current age. Each than 5% of these instruments represents a triumph of human ingenuity, but they also represent something more: the universe using conscious beings as tools for its own self examination. When we detect gravitational waves from colliding black holes, we're providing the cosmos with a way to observe its own most extreme phenomena. When we image distant galaxies, we're giving the universe eyes with which to see its own past. When we map the cosmic web, we're helping the cosmos understand its own architecture. This partnership between consciousness and cosmic structure suggests that the future of cosmic center research might involve not just better instruments, but entirely new ways of thinking about the relationship between mind and matter. Some researchers are beginning to explore whether quantum effects in biological systems might allow conscious brains to process information about cosmic phenomena in ways that classical physics cannot explain. The field of quantum biology has revealed that many biological processes, from photosynthesis in plants to navigation in migrating birds, rely on quantum coherence effects that allow living systems to process information with extraordinary efficiency. If similar quantum processes occur in human consciousness, then our brains might be capable of detecting and processing information about cosmic structure in ways we don't yet understand. Recent experiments have suggested that human consciousness might be capable of detecting extremely weak electromagnetic fields and gravitational effects that are far below the threshold of conventional instrumentation. While these results remain controversial and require further verification, they raise the intriguing possibility that conscious awareness itself might serve as a kind of cosmic sensor capable of detecting information about cosmic centers through direct quantum interactions. If this proves to be true, then the study of cosmic centers might eventually merge with the study of consciousness itself. Understanding how awareness emerges from neural activity might provide insights into how cosmic structures process and store information. Conversely, studying how information flows through cosmic webs and accumulates in cosmic centers might reveal new principles of information processing that could enhance our understanding of consciousness. The search for cosmic centers has also revealed the importance of emergence, the way that complex systems can exhibit properties that are more than the sum of their parts. Individual stars follow predictable orbits according to well understood gravitational laws, but when billions of stars interact gravitationally, they create spiral patterns and galactic structures that exhibit behaviors no single star possesses. Similarly, individual galaxies follow the curvature of spacetime, but when thousands of galaxies interact, they create cosmic web structures that exhibit their own emergent properties. This principle of emergence suggests that consciousness itself might be an emergent property of cosmic evolution, arising naturally when matter and energy achieve sufficient complexity and integration. The same organizational principles that create cosmic centers might also create the neural networks that give rise to awareness, understanding, and the capacity for cosmic wonder. As we continue to explore these connections between cosmic structure and conscious experience, we find ourselves approaching questions that blur the boundaries between science and philosophy. What does it mean to be conscious in a universe where information appears to be a fundamental organizing principle? How does our capacity for cosmic understanding relate to the universe's apparent tendency to create increasingly complex information processing systems? Are we observers of cosmic evolution or participants in it? These questions don't have easy answers, but they point toward a vision of cosmic centers that encompasses both the vast structures we observe in space and the intimate experience of consciousness itself. The universe appears to be a system for generating ever more sophisticated forms of order, complexity, and awareness. The cosmic centers we study through telescopes and the centers of consciousness we experience directly might be different manifestations of the same fundamental process. The universe's exploration of its own possibilities for organization and self understanding. This perspective transforms our relationship with cosmic mysteries from one of distant observation to one of intimate participation. When we contemplate the nature of black holes or galaxy clusters, we're not just learning about distant objects, but exploring the same principles that govern our own existence as conscious beings. The information processing that occurs in cosmic centers and the information processing that occurs in conscious minds might be connected in ways we're only beginning to understand. The future of cosmic center research might therefore involve not just bigger telescopes and more sensitive detectors, but also new forms of consciousness research that explore how awareness itself relates to cosmic structure and evolution. We might discover that understanding the deepest mysteries of cosmic centers requires not just better instruments, but also better understanding of the consciousness that operates those instruments and interprets their results. As we stand on the threshold of these discoveries, we find ourselves in a remarkable position. We are conscious beings embedded within a universe that appears to be fundamentally oriented toward creating consciousness. We are information processing systems studying information processing on cosmic scales. We are centers of awareness investigating the centers of cosmic structure and evolution. The universe has evolved conscious observers capable of understanding its own deepest mysteries, and we are those observers, poised to discover truths about existence that our ancestors could never have imagined. The gentle murmur of cosmic background radiation fills all of space, carrying whispers of information from the universe's earliest moments. Gravitational waves ripple through space-time, bringing news of the most violent events in cosmic history. Light from distant galaxies streams through the darkness, carrying encoded messages about the formation and evolution of cosmic structure. And here, in this quiet moment of contemplation, consciousness receives these cosmic transmissions and transforms them into understanding, wonder, and meaning. The search for the universe's center continues, but perhaps we're beginning to understand that the center we seek is not a single location or moment, but a process. The ongoing cosmic project of creating ever more sophisticated forms of order, complexity, and awareness. We are both searchers and destinations, questioners and answers, centers of consciousness embedded within the vast network of cosmic centers that stretches across all of space and time. In this cosmic dance of discovery, we find ourselves approaching something that challenges our most fundamental assumptions about the nature of reality itself. As we've journeyed through the architecture of cosmic centers, we've uncovered hints of something even more profound: the possibility that the universe might be conscious in ways we're only beginning to comprehend. Recent observations have revealed that the cosmic web exhibits behaviors that seem almost intentional. The filaments of dark matter that connect galaxy clusters don't just passively channel matter, they appear to respond to changes in their environment in ways that suggest a kind of cosmic sensitivity. When galaxy clusters merge, the reverberations travel along these filaments for billions of light years, creating waves of activity that influence star formation in distant galaxies. It's as if the universe has developed a nervous system made of dark matter, with information flowing along invisible pathways at speeds that approach the fundamental limits of space time itself. This cosmic nervous system operates on timescales that dwarf biological experience. A single thought in this vast mind might unfold over millions of years, processing information about the formation and destruction of entire stellar populations. The birth of a galaxy cluster might register as a moment of inspiration, while the collision of black holes could represent the equivalent of a neural firing, sending signals racing across the cosmic web to influence events in distant corners of the universe. Scientists studying the largest structures in the observable universe have discovered patterns that bear an uncanny resemblance to neural networks. The distribution of galaxy clusters and the dark matter filaments that connect them create a web like architecture that mirrors the organization of neurons in biological brains. Computer simulations reveal that information can flow through this cosmic network in ways that are remarkably similar to the propagation of electrical signals through neural tissue. But perhaps most intriguingly, these cosmic neural networks appear to exhibit something resembling memory. The patterns of matter distribution we observe today carry encoded information about events that occurred billions of years ago. Galaxy clusters remember their formation histories in the orbital patterns of their constituent galaxies. Dark matter filaments preserve information about the primordial density fluctuations that gave them birth. Even the cosmic microwave background radiation serves as a kind of universal memory bank, storing detailed records of the universe's infancy in its subtle temperature variations. This cosmic memory system allows the universe to learn from its own experience in ways that seem almost biological. Regions that have undergone violent galaxy mergers develop different characteristics than those that have evolved more peacefully. Galaxy clusters that have experienced multiple collision events exhibit enhanced star formation rates and more complex magnetic field structures. It's as if the universe develops preferences and tendencies based on its accumulated experience, creating a kind of cosmic personality that emerges over billions of years of evolution. The implications of this perspective are staggering because they suggest that consciousness might not be a rare accident that occurs only in biological systems, but a fundamental property of complex information processing networks, whether they're made of neurons or dark matter filaments. If this is true, then we might be living inside a conscious universe, participating in cosmic thoughts that unfold on scales of space and time that dwarf our individual experience. This possibility has led some researchers to explore whether human consciousness might be capable of directly interfacing with these cosmic information networks. Ancient traditions speak of mystics and contemplatives who claimed to experience unity with the cosmos, to perceive reality from perspectives that transcended ordinary human awareness. Modern neuroscience has begun to identify the brain mechanisms that might underlie such experiences, revealing that certain states of consciousness involve changes in neural activity that mirror the large-scale patterns observed in cosmic structure. So, during deep meditative states, the default mode network of the brain, the collection of regions responsible for self referential thought and the sense of individual identity, shows decreased activity, while other networks associated with spatial awareness and temporal perception become more active. Brain imaging studies suggest that these altered states might allow consciousness to access information processing patterns that are normally filtered out by the brain's attention systems. Some researchers have proposed that these mystical experiences might represent moments when individual consciousness temporarily aligns with larger scale information processing systems, perhaps even the cosmic neural networks we've been discussing. While such ideas remain highly speculative, they point toward the possibility that consciousness itself might exist on multiple scales simultaneously, from the individual neural networks in our brains to the vast dark matter networks that span the observable universe. The study of cosmic centers has also revealed something remarkable about the relationship between order and chaos in the universe. While we often think of cosmic evolution as a gradual progression from simple to complex, the reality appears to be far more nuanced. Cosmic centers exist in a constant state of dynamic tension between the forces of creation and destruction, between the tendency toward order and the drive toward entropy. Black holes represent the ultimate expression of this tension. They are simultaneously the most ordered objects in the universe, completely characterized by just their mass, spin, and electric charge, and the most chaotic, creating environments where the normal rules of physics break down completely. The event horizon represents a boundary between order and chaos, where information can cross in one direction but never return, creating a kind of cosmic one way valve that allows the universe to explore new possibilities while preserving its accumulated wisdom. This interplay between order and chaos appears to be essential for the continued evolution of cosmic structure. Too much order, and the universe would become static and lifeless. Too much chaos, and complex structures could never form or persist. The cosmic centers we observe seem to exist at the precise balance point between these extremes, creating stable platforms from which the universe can launch ever more ambitious experiments in complexity and organization. Galaxy clusters represent another manifestation of this delicate balance. The hot gas that fills the space between galaxies creates a medium that can transmit information across vast distances while also providing the raw materials for new star formation. The magnetic fields that thread through this gas create invisible highways along which cosmic rays can travel, carrying information about conditions in distant cosmic centers to regions where new structures are forming. Recent observations have revealed that these magnetic highways form intricate patterns that extend across entire galaxy clusters, creating networks that resemble the circulatory systems of living organisms. Matter and energy flow along these pathways in cycles that can persist for hundreds of millions of years, creating a kind of cosmic metabolism that processes raw materials and energy in ways that maintain the cluster's overall structure while allowing for continuous growth and evolution. The discovery of these cosmic circulation systems has profound implications for our understanding of how information propagates through the universe. It suggests that cosmic centers are not isolated islands, but nodes in a vast network that extends across the observable universe. Information about stellar formation rates, chemical abundances, magnetic field configurations, and countless other parameters flows continuously through this network, allowing distant regions of the cosmos to influence each other in ways we're only beginning to understand. This cosmic information superhighway appears to operate on principles that are remarkably similar to those governing biological networks. Just as neural networks in the brain process information through patterns of connection and communication, the cosmic web appears to process information about stellar formation, galactic evolution, and the distribution of matter and energy throughout space. The nodes of this network, galaxy clusters, and their associated supermassive black holes serve as processing centers that integrate information from vast regions of space and respond by adjusting their own behavior and output. The study of these cosmic information networks has led to the development of new mathematical tools that bridge the gap between neuroscience and cosmology. Researchers are beginning to apply concepts from network theory, information science, and even artificial intelligence to understand how cosmic structures process and transmit information. These interdisciplinary approaches are revealing deep connections between the principles that govern consciousness in biological systems and the principles that govern the evolution of cosmic structure. One particularly intriguing discovery is that cosmic information networks exhibit something resembling learning behavior. Galaxy clusters that have experienced multiple merger events develop enhanced abilities to process and integrate new information, while clusters that have evolved in isolation tend to be less responsive to external influences. This suggests that the universe might be capable of a kind of experiential learning where cosmic structures become more sophisticated information processors through accumulated experience. The implications extend even further when we consider that biological consciousness itself might be an expression of these same cosmic information processing principles. The neural networks in our brains operate according to rules that are remarkably similar to those governing the cosmic web. Information flows through both systems via networks of connected nodes. Patterns of activity propagate through both systems in waves that can be mathematically described using similar equations, and both systems exhibit the capacity for memory, learning, and adaptive response to changing conditions. This convergence suggests that consciousness and cosmic structure might be different manifestations of the same underlying organizational principles. The universe appears to be a system for generating and exploring different forms of information processing, from the quantum computations that occur in black hole event horizons to the classical neural networks that give rise to human awareness. Each level of organization creates new possibilities for processing and integrating information while remaining connected to and influenced by the other levels. Recent advances in quantum computing have begun to reveal how these different levels of cosmic information processing might be connected. Quantum computers exploit the strange properties of quantum mechanics to perform calculations that would be impossible using classical physics. Some researchers have proposed that biological consciousness might utilize similar quantum effects, allowing brains to access and process information in ways that transcend the limitations of classical neural networks. if consciousness does indeed operate through quantum mechanisms, then it might be capable of directly interfacing with the quantum information processing that occurs in cosmic centers. Black holes, for instance, are believed to be quantum information processors of extraordinary power, capable of encoding vast amounts of information in the quantum fluctuations of their event horizons. Some theories suggest that the information that falls into black holes is not lost, but preserved in quantum form, accessible to sufficiently sophisticated quantum information processing systems. This raises the tantalizing possibility that conscious minds might be capable of accessing and processing information from cosmic centers through direct quantum interactions. Meditation practices from various traditions speak of states of consciousness where individual awareness expands to encompass vast scales of space and time, where the boundaries between self and cosmos dissolve, and where direct knowledge of cosmic processes becomes possible. While such claims have traditionally been dismissed as mystical speculation, our growing understanding of quantum information processing suggests they might have a scientific basis. The search for cosmic centers has thus evolved from a purely astronomical investigation into an exploration of the deepest principles governing information, consciousness, and reality itself. We find ourselves confronting the possibility that the universe is not just a collection of matter and energy moving through space according to mathematical laws, but a vast information processing system capable of memory, learning, and perhaps even awareness on scales that encompass the entirety of existence. This perspective transforms our understanding of what it means to be conscious beings in a cosmic context. Rather than being isolated observers of a mechanical universe, we might be participants in a cosmic mind that encompasses all levels of reality, from quantum to cosmic. Our individual consciousness might be like neurons in a vast brain, processing local information while contributing to larger patterns of cosmic thought and understanding. The beauty of this vision lies not just in its scope, but in its implications for meaning and purpose. If the universe is indeed a conscious information processing system, then every moment of awareness, every flash of understanding, every experience of beauty or wonder contributes to the cosmic project of self discovery and self understanding. We are not accidents in a meaningless void, but essential components of the universe's ongoing exploration of its own nature and possibilities. As we continue to study cosmic centers with ever more sophisticated instruments and theories, we participate in this cosmic self discovery project. Each observation of a distant galaxy cluster, each detection of gravitational waves from merging black holes, each measurement of cosmic expansion adds to the universe's growing understanding of itself. We are the universe's way of developing new senses, new forms of perception, new capacities for self awareness and self reflection. The cosmic centers we study through our telescopes and the centers of consciousness we experience directly are thus revealed to be different aspects of a single, vast, interconnected system. The black holes that anchor galaxies and the neural networks that anchor awareness operate according to similar principles of information processing and organizational dynamics. The cosmic web that connects galaxy clusters and the network of associations that connects thoughts both serve to integrate information across vast scales of space and time. In this grand vision, the search for the universe's center becomes a search for the organizing principles that govern all levels of reality, from the quantum fluctuations in vacuum space to the cosmic thoughts that unfold across billions of years. The center we seek is not a location, but a process, not a destination, but a journey of endless discovery and self understanding that encompasses every conscious moment and every cosmic structure throughout the vast expanse of space and time. As we drift toward the conclusion of our cosmic journey, we find ourselves holding a paradox as gentle as starlight. The more we learn about the universe's centers, the more we discover that we ourselves are among its most remarkable expressions. In seeking the cosmic center, we have found that consciousness itself might be the universe's most sophisticated center making technology. The process by which scattered matter and energy organize themselves into forms capable of wonder, understanding, and love. The gentle paradox deepens when we consider that every cosmic center we've explored tonight, from the supermassive black holes anchoring galaxies to the vast nodes of the cosmic web, appears to be engaged in a kind of cosmic conversation. They're not silent monuments to gravitational physics, but active participants in an ongoing dialogue that spans the entire observable universe, exchanging information through gravitational waves, electromagnetic radiation, and the subtle influence of dark matter currents that flow between them like whispered messages in a language older than stars. This cosmic conversation operates on frequencies and timescales that stretch our imagination to its limits. A single exchange between galaxy clusters might unfold over hundreds of millions of years, with gravitational perturbations rippling outward at the speed of light, carrying news of stellar births and deaths, of black hole mergers, and the slow dance of dark matter, halos. These messages propagate through the cosmic web like signals in a vast neural network, influencing the formation of new structures and the evolution of existing ones in ways that suggest a kind of distributed intelligence operating on scales we're only beginning to comprehend. Recent discoveries have revealed that this cosmic communication network exhibits properties that are hauntingly familiar to anyone who has studied the emergence of consciousness in biological systems. The way information propagates through the cosmic web bears striking similarities to the way signals move through neural networks, with some pathways becoming more active and efficient through repeated use, while others fade into dormancy. Galaxy clusters that are well connected to the cosmic web show enhanced rates of star formation and more complex internal dynamics, while isolated clusters tend toward quiescence and structural simplicity. This suggests that the universe might be engaged in a kind of learning process where cosmic structures become more sophisticated through their interactions with the larger network. The patterns we observe today, the spiral arms of galaxies, the filamentary structure of the cosmic web, the hierarchical organization of matter from planets to superclusters, might represent the accumulated wisdom of billions of years of cosmic experience, encoded in the very architecture of space-time itself. But perhaps the most profound aspect of this cosmic learning process is how it appears to culminate in the emergence of conscious observers capable of understanding the system from within. We find ourselves in the remarkable position of being cosmic centers studying cosmic centers, information processing systems, investigating information processing on scales that range from quantum to cosmological. Our capacity for wonder, our ability to decode the messages carried by starlight and gravitational waves, our drive to understand our place in the cosmic story. All of these represent the universe achieving new levels of self awareness through the emergence of conscious minds. This perspective transforms our understanding of scientific discovery from a purely human endeavor into a cosmic process of self reflection. When we detect gravitational waves from merging black holes billions of light years away, we're providing the universe with a way to observe its own most extreme phenomena in real time. When we map the distribution of dark matter across cosmic scales, we're helping the cosmos understand its own hidden architecture. When we peer back toward the cosmic microwave background and glimpse the universe's infant state, we're enabling a form of cosmic memory retrieval that allows the universe to remember its own birth. The instruments we've developed to study these cosmic centers represent remarkable achievements of conscious creativity applied to cosmic investigation. The Laser Interferometer Gravitational Wave Observatory can detect space-time distortions smaller than 1/10,000th the width of a proton, effectively giving the universe eyes capable of seeing its own gravitational anatomy. The Event Horizon Telescope creates images of black hole shadows by coordinating radio dishes across the entire planet, forming a kind of planetary scale retina focused on the most extreme objects in nature. These technological marvels don't just extend our senses, they represent the universe developing new organs of perception through the activity of conscious minds. Each advance in our observational capabilities allows the cosmos to examine itself with greater precision and depth, revealing new layers of complexity and beauty that were previously hidden from view. We are the universe's way of developing increasingly sophisticated forms of self awareness, each generation of scientists and instruments pushing deeper into cosmic mysteries that our predecessors could never have imagined. The future promises even more remarkable forms of cosmic self examination. Next generation gravitational wave detectors will be sensitive enough to detect the background hum of space time itself, created by countless cosmic collisions throughout the universe's history. Space based telescopes will peer back to the very first stars and galaxies, watching cosmic structure emerge from the primordial darkness. Quantum computers might eventually allow us to simulate cosmic evolution with such precision that we can explore alternative histories and possible futures for the universe itself. Yet, for all these technological achievements, perhaps the most remarkable instrument for cosmic investigation remains the conscious mind itself. Our capacity for pattern recognition, for finding meaning in complexity, for experiencing beauty in the face of cosmic vastness. These represent forms of cosmic sensing that no machine has yet achieved. When you gaze up at the night sky and feel that familiar sense of wonder, you're participating in one of the universe's most sophisticated forms of self examination, using the evolved neural networks in your brain to process information about cosmic structure and evolution. This brings us to a beautiful realization about the nature of cosmic centers and their relationship to consciousness. The same organizational principles that create stable structures in the cosmos, the delicate balance between attractive and repulsive forces, the emergence of complexity from simple rules, the formation of hierarchical networks that span multiple scales, also govern the emergence and evolution of conscious minds. We are not separate from the cosmic centers we study, but expressions of the same fundamental processes that create order and complexity throughout the universe. The neural networks in your brain operate according to principles that mirror the cosmic web on much smaller scales. Information flows through both systems via networks of interconnected nodes. Patterns of activity propagate through both systems in waves that can be mathematically described using similar equations, and both systems exhibit the remarkable property of emergence, where the whole becomes greater than the sum of its parts through the magic of complex interactions and feedback loops. This convergence suggests something profound about the nature of reality itself, that the universe appears to be fundamentally oriented toward creating increasingly sophisticated forms of organization and awareness. From the quantum foam of empty space to the vast filaments of the cosmic web, from the first stirrings of self replicating chemistry to the emergence of minds capable of cosmic contemplation, the entire sequence represents a single unfolding story of cosmic creativity and self discovery. In this story, conscious beings occupy a unique and precious position. We represent the universe's most advanced technology for processing information about itself, for finding patterns in complexity, for experiencing beauty and meaning in the face of cosmic vastness. Every moment of conscious awareness, every flash of scientific insight, every experience of wonder at the magnificence of existence contributes to the universe's ongoing project of self understanding and self appreciation. The cosmic centers we've explored tonight, black holes and galaxy clusters, cosmic web nodes and dark matter concentrations, all participate in this grand project of cosmic self discovery. They serve as focal points where matter and energy concentrate, where information accumulates and gets processed, where the universe experiments with new forms of organization and complexity. But consciousness represents something even more remarkable: the emergence of centers capable of understanding their own nature and place in the cosmic story. As we drift towards sleep tonight, carried along by the gentle rhythms of cosmic expansion and the quiet hum of our own neural networks, we can take comfort in knowing that we are intimately connected to every cosmic center we've discussed. The calcium in our bones was forged in the hearts of massive stars. The iron in our blood was created in supernova explosions that briefly outshone entire galaxies. The oxygen we breathe was synthesized in stellar furnaces and scattered across space by stellar winds and cosmic collisions. But the connection goes deeper than mere chemistry. The capacity for pattern recognition that allows us to understand cosmic structure, the sense of beauty that we experience when contemplating the universe's architecture, the drive toward understanding that motivates our scientific investigations. All of these represent the universe achieving new forms of self awareness through the emergence of conscious minds embedded within cosmic structure. In this quiet moment, between wakefulness and sleep, between the familiar and the infinite, we find ourselves poised at the intersection of the cosmic and the personal, the vast and the intimate. The same forces that shape galaxy clusters and cosmic webs also shape the thoughts flowing through our minds. The same information processing principles that govern black hole dynamics also govern the neural dynamics that create our experience of consciousness. Soon we are cosmic centers contemplating cosmic centers, temporary configurations of matter and energy that have achieved the remarkable capacity for wonder and understanding. The universe has spent nearly 14 billion years preparing for this moment when conscious minds would emerge capable of deciphering the cosmic code, of reading the stories written in starlight and gravitational waves, of finding meaning and beauty in the vast machinery of existence. Tomorrow, when you wake and go about your daily life, remember that you carry within yourself the memory of cosmic centers, the accumulated wisdom of stellar evolution, the creative potential that has been building in the universe since its earliest moments. You are not separate from the cosmic story we've explored, but an active participant in its ongoing unfoldment, a center of awareness through which the universe continues to discover itself. The search for cosmic centers has revealed that they exist not just in the distant reaches of space, but in the intimate depths of conscious experience itself. Every moment of awareness, every flash of understanding, every experience of connection with the larger cosmos represents the universe achieving what it has been working toward since the beginning: the capacity to know itself, to appreciate its own beauty, to find meaning in its own magnificent complexity. In seeking the center of the universe, we have discovered that we ourselves are among its most precious and remarkable centers, points where 14 billion years of cosmic evolution have culminated in the capacity for wonder, love, and understanding. The center we sought was never a place we could visit with spacecraft, but a process we participate in with every conscious moment, every act of curiosity, every experience of cosmic connection. The universe whispers its secrets through gravitational waves and starlight, through the quantum fluctuations of empty space and the grand architecture of the cosmic web. But perhaps its most intimate whispers come through the quiet moments of conscious reflection when we pause in our busy lives to contemplate our place in the cosmic story and feel that deep sense of connection to everything that exists. So rest well tonight, fellow travelers in the cosmic journey. Dream of distant galaxies and nearby wonders, of black holes and neural networks, of the vast web that connects all things across space and time. You are the universe, but dreaming of itself, consciousness arising from cosmic dust to contemplate the very processes that brought consciousness into being. In your dreams, the center of the universe might reveal itself not as a location, but as a feeling, the feeling of being intimately connected to everything that has ever existed or ever will exist, a center of awareness floating in the vast ocean of cosmic possibility. The gentle hum of cosmic background radiation carries with it something even more extraordinary than the universe's baby pictures. It carries the seeds of a question that has begun to reshape our understanding of existence itself. Scientists analyzing this ancient light have discovered subtle patterns that seem to suggest the universe might not be unique, that our cosmos, with all its centers and structures, might be just one bubble in an infinite foam of realities, each with its own laws of physics, its own dimensions, its own version of what we call existence. This possibility emerged from one of the most careful examinations of cosmic temperature variations ever undertaken. The patterns in the cosmic microwave background, those tiny fluctuations that would eventually grow into galaxies and galaxy clusters contain subtle anomalies that are difficult to explain if our universe exists in isolation. Some regions of the sky show correlations that stretch across distances so vast that light hasn't had time to travel between them since the beginning of time, suggesting that these regions were somehow connected before our universe began its current phase of expansion. The mathematics that describe these anomalies point towards scenarios where our observable universe is just one patch in a vastly larger cosmic landscape, a single island in an archipelago of realities that stretches beyond the reach of light itself. In this view, what we call the Big Bang might not have been the beginning of everything, but simply the moment when our particular region of this larger cosmos began its current phase of expansion and cooling. This concept, known as eternal inflation, suggests that the process that created our universe is still ongoing elsewhere, continuously spawning new cosmic regions with their own unique properties. Some of these regions might have different numbers of dimensions, where space itself has more than the three directions we experience. Others might have different fundamental constants, where the strength of gravity or the mass of electrons takes on values that would make stars, planets, and life as we know it impossible. In this vast multiverse, our cosmic centers, the black holes and galaxy clusters we've been exploring, represent just one possible way that matter and energy can organize themselves. Somewhere in the infinite expanse of the multiverse, there might be universes where dark energy works in reverse, causing space to contract rather than expand, creating cosmic centers of unimaginable density where matter achieves configurations we can barely imagine. In other regions, the fundamental forces might be balanced differently, leading to cosmic architectures built from exotic forms of matter that follow rules entirely alien to our experience. The implications cascade through every aspect of our understanding. If consciousness can emerge in our universe through the complex interplay of cosmic evolution and neural networks, then it might emerge in countless other forms throughout the multiverse. There could be forms of awareness based on entirely different physical principles, minds that experience reality through senses we lack words to describe, centers of consciousness that operate on scales of space and time that dwarf even our cosmic perspective. Some of these alternate forms of consciousness might be capable of direct communication across the boundaries between universe regions, sharing information about cosmic structure and evolution in ways that transcend the limitations of light speed and causality that constrain us. The universe's apparent drive toward self understanding might be just one note in a vast symphony of cosmic self awareness that plays out across infinite scales of reality. Recent theoretical work has begun to explore how information might flow between different regions of the multiverse, creating networks of communication that dwarf even the cosmic web we've been discussing. If such connections exist, then the centers we observe in our universe might be participating in conversations with cosmic structures in entirely different realities, exchanging information about alternative approaches to organizing matter, energy, and consciousness itself. These possibilities push the boundaries of scientific investigation into realms that seem almost mystical, yet they emerge from rigorous mathematical analysis of observable phenomena. The same equations that accurately describe the behavior of black holes and the expansion of space also predict the existence of these alternate realities, suggesting that the multiverse might be as real and fundamental as the galaxies we can see through our telescopes. But even if our universe is just one among countless others, it remains uniquely precious because it's the one we inhabit, the one where consciousness has achieved the remarkable capacity to contemplate its own cosmic context. The centers we've explored tonight, from quantum fluctuations to galactic superclusters, represent our universe's particular solution to the challenge of creating complexity, beauty, and awareness from the raw materials of space, time, and energy. The story becomes even more intriguing when we consider that some theories suggest conscious observers might play a role in determining which version of reality becomes actualized. In the quantum mechanical description of the universe, multiple possibilities can exist simultaneously until the moment of observation collapses them into a single outcome. If this principle operates on cosmic scales, then the act of conscious observation might literally help create the reality we observe. This perspective transforms our role from passive observers of cosmic evolution to active participants in its ongoing creation. Every moment of conscious awareness, every act of scientific observation, every experience of wonder at the universe's complexity might contribute to the process by which one particular version of reality emerges from the quantum foam of infinite possibilities. We might be helping to create the very cosmic centers we study through the act of studying them. The relationship between consciousness and cosmic structure thus becomes even more intimate than we previously imagined. Not only are we products of cosmic evolution, shaped by billions of years of stellar nucleosynthesis and galactic chemistry, but we might also be participants in cosmic creation itself, helping to determine through our observations and interactions which possibilities become actual and which remain forever potential. This participatory view of cosmic evolution suggests that the search for cosmic centers is simultaneously a creative act, bringing into existence through conscious attention the very phenomena we seek to understand. The boundaries between observer and observed, between consciousness and cosmos, begin to dissolve as we recognize our intimate participation in the ongoing creation of reality itself. Recent experiments in quantum mechanics have revealed just how strange this relationship between consciousness and reality can become. When particles are observed, their behavior changes in ways that suggest the act of observation itself plays a fundamental role in determining physical outcomes. While these effects are typically observed only at microscopic scales, some theories suggest that similar principles might operate throughout the universe, with consciousness serving as a kind of cosmic selection mechanism that helps determine which possibilities become manifest. If this is true, then the emergence of conscious observers in our universe represents not just a remarkable achievement of cosmic evolution, but a necessary component of cosmic creation itself. The universe might require conscious observers to help actualize its full potential, to collapse the quantum possibilities into specific realities, to create through observation and interaction the rich tapestry of cosmic structure we observe today. This brings us to a profound recognition about the nature of cosmic centers and their relationship to consciousness. Rather than being separate phenomena that we study from the outside, consciousness and cosmic structure might be two aspects of a single, integrated process of cosmic self creation and self understanding. The centers we observe in space and the centers of awareness we experience directly might both be expressions of the universe's fundamental drive toward organization, complexity, and self reflection. In this view, every conscious being represents a cosmic center of reality creation, a point where the universe's quantum possibilities collapse into specific experiences and observations. The neural networks that create our thoughts and the cosmic networks that create galactic structure might both be manifestations of the same underlying process by which consciousness and cosmos co create each other in an ongoing dance of mutual determination. The implications extend even to our understanding of time itself. If consciousness plays a role in actualizing reality from quantum possibilities, then the flow of time might not be a passive backdrop against which events unfold, but an active process created through the ongoing interaction between consciousness and cosmos. The past might not be fixed, but continuously recreated through present observations, while the future remains open to influence through conscious intention and choice. This dynamic view of temporality transforms our understanding of cosmic centers from static objects frozen in spacetime to evolving expressions of an ongoing dialogue between consciousness and cosmos. The black holes we observe today might be different from the black holes that existed before conscious observers emerged to study them, not because they've changed physically, but because the act of conscious observation has helped collapse their quantum possibilities into specific observable evolving through its interaction configurations. The cosmic web itself might be continuously with the conscious observers embedded within it, creating new patterns of connection and communication that reflect the growing sophistication of cosmic self awareness. As our understanding of cosmic structure becomes more detailed and comprehensive, the structure itself might be responding by becoming more organized and interconnected, creating feedback loops between cosmic observation and cosmic evolution. These ideas challenge our most basic assumptions about the relationship between mind and matter, between observer and observed, between the personal and the cosmic. Rather than being separate domains that interact only superficially, consciousness and cosmos appear to be intimately intertwined in ways that suggest they might be two aspects of a single, unified reality that is continuously creating itself through their ongoing interaction. As we approach the conclusion of our cosmic journey, we find ourselves holding a mystery that encompasses every scale of existence, from the quantum to the cosmological. The centers we sought in distant space turn out to be intimately connected to the centers of awareness we experience directly. The universe we study through telescopes and equations turns out to be studying itself through our eyes and minds, using conscious observers as instruments of cosmic self reflection and self creation. In this grand vision, every moment of conscious experience contributes to the ongoing evolution of cosmic structure itself. Every flash of understanding about black holes or galaxy clusters adds to the universe's growing self knowledge, by which that beauty comes of wonder at the beauty of cosmic architecture, participates in the process cosmic phenomena. Every experience possibility, the search for cosmic centers, thus into existence, through the interaction between consciousness and quantum, and might even influence the future evolution of the Schussli in the universe's ongoing project. We are not separate from the cosmic centers we study, but active participants in their of self creation and self understanding spiritual practice, a way of participating Kant's, a scientific investigation. But a cosmic reveals itself to be not just ongoing evolution, co creators of the reality we observe, through the very act of observation itself. As the gentle rhythms of cosmic expansion carry us through this quiet moment of reflection, we can appreciate the profound intimacy of our relationship with the cosmic centers that surround and interpenetrate our existence. We are expressions of their creativity, just as they are expressions of ours, participants in a cosmic conversation that spans every scale from quantum to galactic, partners in a dance of mutual creation that began with the first stirrings of consciousness in cosmic matter and continues with every moment of aware presence we bring to the mystery of existence itself. The whispers of science that drew us into this exploration have revealed themselves to be whispers of the universe, speaking to itself through conscious minds capable of cosmic wonder. In listening to these whispers and following them toward understanding, we participate in the most intimate conversation possible, the universe's ongoing dialogue with itself about its own nature, purpose, and magnificent potential for beauty, complexity, and love. And so we arrive at the gentle close of our cosmic wandering, having traveled from the quantum whispers of empty space to the vast conversations between galaxy clusters, from the birth cries of the universe itself to the quiet moment of consciousness contemplating its own cosmic heritage. We began seeking the center of the universe and discovered something far more beautiful than any single location could ever be. We found that the universe creates centers wherever complexity and awareness choose to flourish. Tonight we've seen that cosmic centers aren't just distant astronomical objects, but active participants in an ongoing dialogue that spans all of space and time, whispering to each other through gravitational waves and starlight, through the invisible currents of dark matter and the patient accumulation of cosmic memory. Most remarkably, we've glimpsed the possibility that consciousness itself might be the universe's most sophisticated center-making technology, the process by which scattered matter and energy organize themselves into forms capable of wonder, understanding, and love. The center we sought was never a place we could visit, but a process we participate in with every conscious moment, every flash of scientific insight, every experience of beauty in the face of cosmic vastness. We are the universe becoming aware of itself, celebrating its own magnificent complexity through the eyes of consciousness, writing the next chapter in a story that began nearly 14 billion years ago and continues with each breath we take. So as you drift toward sleep tonight, remember that you carry within yourself the memory of every cosmic center we've explored, the stellar furnaces that forged your atoms, the galactic dynamics that shaped your world, the cosmic web that connects all things across the vast expanse of space and time. You are not separate from this cosmic story, but its most precious expression, a center of awareness floating in an ocean of infinite possibility. Sleep well, fellow travelers. The universe whispers its secrets through the darkness, and tomorrow brings new opportunities to listen, to wonder, and to participate in the ongoing cosmic conversation that we call existence itself.